Right, question 11. It is a scale drawing question. Now, so many people, so many students lose marks on this because they don't actually do a scale drawing. Very straightforward doing this using Pythagoras and trigonometry, but as we can see here, it says draw a labeled vector diagram to scale and use it to find the actual true velocity of the rain. Okay, so if you're not going to use it, you're not going to get the marks. Okay, but it's not as straightforward a premise as a lot of vector questions, but let's try and sort of think this out. Okay, always a diagram's nice. We've got rain that's falling. Okay, now it appears to the man that it's falling vertically downwards, but there's a man walking into the rain. Okay, so there he is there. Okay, he's walking into the rain, so the rain is actually going to have, relative to the man, a component of velocity in that direction, isn't it? Okay, he's walking to the left, so relative to the man, the rain is moving to the right, horizontally, sorry. Okay, the man's walking horizontally to the left, the rain is moving horizontally to the right relative to the man. Okay, now it appears as though it's falling vertically downwards. So again, we're just trying to map it out in our head more than anything here. So the resultant velocity of the rain is vertically downwards. So as we can see, there's two components. There's going to be the component due to the man walking, which is 1.8 meters per second. Now, that means that the rain must actually be traveling in that direction. Okay? Now, the speed of the rain in that direction is 1.8. That's wrong there. That should be 1.2. Okay? So the man's walking to the right at 1.2, so the rain is moving to the left at 1.2. But the rain, the actual velocity is coming downwards. So we've got those two purple vectors added together to produce the resultant, which is what the man perceives the rain to be doing. Okay, now we could, like I said, use Pythagoras and trigonometry, and that would be fairly straightforward, but we're not. We need to draw a scale drawing. Okay, you will very often see scale drawings. In fact, more often than not, you'll be asked to draw a scale drawing on a grid and some graph paper. But you were not given it in this case because two of the vectors are perpendicular. So you should be skilled enough with your ruler and protractor to draw a nice scale drawing without graph paper. Okay, so all we had to do here was to draw this nice and neatly to scale. So what we'd want the, okay, we could draw vertical like that. Okay, and then with our ruler, once we've figured out our scale, we're going to draw in something that represents 1.2. And then we're going to use our ruler again and draw something that represents exactly 1.8. Okay, and have them both attached to the vertical like that. And all we need to do then is figure out the length of that using our scale. Okay, and it does say angle-wise, angle. It's the angle to the vertical. So it's this angle here, which you need to measure with your protractor. Right, scale drawing's not as straightforward as sometimes you maybe think they are. Okay, so it takes a little bit of thinking out there, but yeah, please, let's make sure we can use the ruler and protractor in tandem to draw scale drawing. Thank you.